Good day everyone, and welcome to this lecture in the series of systematic reviews and critical appraisal on the topic of quality assessment. We subtitle this one Weighing Up the Evidence, because when you're judging the quality of a included study for a review, it's very much a process of the weighing on one hand the certainty of the evidence, and on the other any threats to the rigour or validity of that study. So let's just recap about where we are in the systematic review process. We've gone through a process of scoping and protocol. At that point we will have identified the type of studies that we'll be including, and so have an early idea about the tool that we'll be using for quality assessment. We will have named it and identified beforehand any issues that we anticipate. We've gone through a process of study identification, searching databases and selecting by sifting through against inclusion criteria. And now we're into a substantive part of the process of quality assessment and data extraction. And these three stages, as listed here, are an important part of the review and will consume quite a lot of time. There's no particular order in which these may be undertaken. They tend to be associated with each other time-wise. We have the assessment of the quality of the study. We have assessment of study characteristics in terms of such things as the study design and the sample size. And then we have the extraction of the study results. And once we've completed this in the engine room, if you like, of the review, then we're able to proceed to the subsequent stages of synthesis, interpretation, and then ultimately dissemination. So during this particular session, we're going to look at what we mean by quality assessment in a systematic review context, how we undertake a quality assessment, and consider how that assessment might be factored in when we come to analysing the evidence. And this particular lecture fits in with some of the workshop activities related to critical appraisal of an individual randomised controlled trial and critical appraisal of a qualitative study. Just a little word about terminology. Within SHA we tend to use the word critical appraisal for the process of looking at an individual article to assess its quality, but quality assessment is the process of looking at a number of studies in that particular way within the context of a systematic review. Now, Karl Popper, a famous philosopher of science, said that if we're uncritical, that we'll always find what we want. We'll always look for that and find confirmation, and that's dangerous because it means that we're blinkered, if you like, and in this way we might go for what we might call the low-hanging fruit, rather than testing our own pet theories more critically. And we can see the impact of this. This dates from the so-called measles, mumps and rubella scare, where we saw a growth in measles cases following a particular scare, and we might wonder what the cause of that is, and when we see the accompanying data around MMR immunization, we can see a potential explanation. And the reason for this was the uncritical acceptance, particularly by the British public, of the so-called evidence around the link between measles, mumps and rubella and autism. and that link has subsequently been discredited, but it had a popular hold on the awareness of people contemplating immunization of their young children. Of course, such uncritical news items are becoming increasingly common in the context of COVID-19. We see here a claim from a herbalist in Turkey that he can cure the coronavirus, and claims a success rate of 95% or 100%. And this is from a position of acknowledged ignorance, and we need to be able to assess these reports. In this particular case, this is from a media site, and so we perhaps start criticizing the content on the basis of the source, but this picture becomes more complicated when we have the medical literature, and we're looking at evidence to see whether the treatments advocated or at least examined in the medical literature can have the potential to make a difference. And so we need to develop as health professionals, as researchers, and as members of the public, skills of being able to critically appraise scientific reports and see how much trust and subsequent action that we can attribute to them. We might think that in the overall scheme of things, a bit like this smoothie that covers a multitude of sins, that being able to spot the rotten fruit, if you like, is just a minor issue, but of course more commonly we find that studies may themselves be flawed, and being able to spot those can help us both in terms of a good use of our time and in terms of the certainty of our evidence and subsequent decisions. So what sort of considerations do we think about when we're trying to assess whether we can believe the claims from a research report? Well, we start very clearly with some of the considerations of study design. This is an algorithm from the Center for Evidence-Based Medicine website which shows a number of the provisions put in terms of study design to help definitively address a particular research question. And each of these excuse me, each of these stages carries some form of protection against the possible influence of bias. And you'll remember from our early lecture that systematic reviews are specifically designed to address concerns of bias, and obviously that's at the level of the review itself, but we're also concerned about the presence of bias in the individual contributing studies. And so, for example, the existence of randomisation or the existence of a control group help us in terms of problems with regard to the allocation, or in terms of drawing wrong conclusions. When it comes to selecting a tool for the critical appraisal process, we're interested in a tool that we can use consistently so that our verdicts on the same article are consistent, and that similar articles with similar deficiencies register similarly. We want the process to be transparent so that people can see where our comments are drawn from, and we want the process to be comprehensive in terms of we don't want to be focusing on a particular aspect of quality and letting slip through other equally important aspects. So these characteristics inform our selection of a quality appraisal tool. And it's fair to say that the family of tools falls within three main subgroups. There was a lot of popularity, certainly in the beginning of the quality assessment movement, to use scales so that one could quantify the extent of bias and therefore attribute some sort of score to the quality of a paper. That was then followed by recognition that such scored approaches are flawed, and this led to the development of checklists, of which the CASP checklist that you'll be using for qualitative study is probably the foremost example. But recently we've seen a sort of new generation of domain-based evaluation where particular aspects of bias are targeted and a clear rationale is given for that particular criterion. And these are being developed within the Cochrane collaboration, starting with randomised controlled trials and now with non-randomised trials as well. And this is generally regarded as the state of the art with regard to quality assessment at this point in time. What are we wanting these checklists to do? Well, the focus on many of these checklists is on what we call internal validity, so the characteristics of the study and its ability to limit the potential for bias. Some of these also cover external validity, the extent to which the results of the trials will apply to a wider population. But strictly speaking, this latter dialogue remains part of the interpretation of the evidence. And so within a systematic review, this process of generalizability will be typically performed as a final stage of the review itself, rather than in applying the results of an isolated study after quality assessment of that study. So yes, generalizability is important, but we tend to handle it collectively for the body of evidence at the end of a systematic review rather than individually at the end of each included study. And fundamental to many of the assumptions behind quality assessment and indeed design of systematic reviews is the idea that there is a so-called hierarchy of research design, and it typically would look like this. One has to say that this is very much a hierarchy of effectiveness, because there are certain types of question like qualitative research that are not accommodated by this particular hierarchy. But if we're talking about establishing the effects of a drug, for example, then obviously an isolated case report is regarded as being low quality evidence, but a randomized controlled trial, particularly a number of randomized controlled trials accommodated within a meta-analysis, is regarded as being high quality evidence. But of course that's only part of the story, because within any of these bands or layers you could have a good example of a case report or a good example of a randomized controlled trial, or you could have a poor example, and the amount of trust that you would place on each is dependent therefore on the quality of the individual study and not exclusively on its study design. Now, the randomized controlled trial occupies an equivocal position. On the one hand, it's welcomed as the highest quality of single study design. On the other hand, it's open for a lot of critique and criticism because of recognition that it does have its own limitations, and we need to occupy a balanced position, recognizing, as Berk says here, that the alternatives to a randomized control trial are usually worse. So many of you will be familiar with the process underpinning a randomized controlled trial, that you have assessment for eligibility, and obviously this is something that you have to consider carefully so that you're not artificially excluding people that you would usually be treating with a particular treatment in the real world population. But once you've assessed people for their eligibility within the trial, you then randomize them either to the intervention of interest or to a comparator, and you treat those two groups as a comparison, and then you analyze the occurrence of outcomes by comparing group A with group B. You can see on this particular diagram, these small boxes are the various points at which you may get attrition or a lack of fidelity because of incompleteness. So, for example, some people may refuse to take the treatment, some people may stop taking the treatment, some people may continue to take the treatment, but we don't have the detailed follow-up data. So plenty of aspects of the randomized controlled trial are open to the inclusion of a lack of information, a lack of detail that may undermine our confidence. And so a good quality assessment tool will be able to pick up on some of these concerns. So when we come to these particular causes of incomplete data, we can see that there's the potential for the introduction of bias, bias in the selection, bias in the performance, in the levels of attrition, in our ability to detect a positive outcome, and in the overall reporting. And all of these get in the way between a well-planned study and a final publication. And it's our task, if you like, to be able to recognize the extent to which this is so. Now, selection bias, it relates to how we identify the patients for inclusion in the first place. Typically, we're interested in the method of randomization and in whether any of those involved are aware of how the allocation is being made, and many papers fall short on these accounts or report incompletely or inadequately. In terms of how the Cochrane collaboration tackles the generation of a random sequence, the assessment is regarded as being adequate if the sequences are regarded as suitable to prevent selection bias. We have various things here that are regarded as having different levels of different levels of rigor behind them. So, for example, tossing a coin and shuffling cards. But the important thing is that if the sequences could be impaired or otherwise influenced, in relation to the prognosis, then that introduces potential selection bias. And so some of the manifestly inadequate ways of randomizing include randomizing by date of birth or by day, month or year of admission, where there could be systemic patterns that explain our eventual result. Concealment of allocation is a further consideration, particularly when examining the quality of randomized controlled trials. So again, the Cochrane risk of bias approach is to identify certain ways that concealment of allocation is regarded as being strong or adequate. So for example, having identical drug containers prepared independently, having a central randomization facility that cannot be manipulated. Alternatively, it can be regarded as inadequate if the patients or physicians are able to identify the allocation schedule, or if there's a straightforward alternation of A then B, for example. And it has been shown that the different aspects of allocation can have a very marked effect on the overall results of studies. And so we can see that taking aside the actual effects of particular treatments, that adding an inadequate method of allocation has a very positive effect on the findings of a randomized controlled trial. A further bias is that of performance and detection bias. We know, for example, if pathologists were told that a certain percentage of the sample that they're looking at contain positive results, then this may influence the time and the care with which they examine that particular sample. And so therefore we want them to carry out each assessment independently without a knowledge of the prevalence of either a positive or a negative outcome. So in a therapy context, we rely on blinding to avoid the possibilities of selection bias, and by keeping that blinding throughout the course of the trial, we can help reduce performance bias and detection bias. And again, we can see a marked effect when blinding is absent, that can explain away the overall effect of the trials. And so within the York guidelines and the Cochrane guidelines, the key consideration is whether that blinding is likely to matter in terms of biasing the outcome. And so obviously if an outcome measure is measured objectively, then blinding becomes less important than if it may otherwise be revealed. Attrition bias, we've already flagged that up in the process, and so if there's a marked difference in how the outcomes are measured and followed up, then we have not just an incomplete picture, which we could compensate for statistically, but a bias or skewed picture where we are unable to quantify the extent of the bias. So incompleteness itself is not the problem, it's the fact that that incompleteness is not distributed equally, and therefore skews the pattern of the trial. And you may have heard of the idea of an intention to treat analysis. This follows the groups in the group, or the participants in the groups to which they've originally been allocated, regardless of their subsequent course. So people assigned to tablet A will be analysed as if they took tablet A. Intuitively, this sounds a bit strange, but if you think of the real world, we're interested in what would happen to people who are prescribed the tablets, not just those who keep taking them. Further bias is selective reporting. We can pick outcomes that may make our particular treatment look very favourable, and we may suppress reports of adverse events, perhaps minimising their extent or omitting them altogether. And then at a meta-study level, we have the possibility of publication bias, so that certain reports don't get out there into the public domain or are harder to retrieve, and therefore we have an incomplete overall picture of how the treatment performs across multiple studies. So having identified some of these major forms of bias, what can we do following the process of quality assessment? Well, we have a number of alternatives, a bit like the program SNOG, marry or avoid. We have mediate, moderate or exclude. So mediate would be where we look at the effect of a particular criteria, and through something like, for example, multiple regression analysis, we look to see the extent to which a criterion might explain away a difference in results. Moderate is a more sort of qualitative judgment of cautioning our findings in the light of the uncertainties around the quality, and then the most extreme position is to actually exclude studies on the basis of quality. One common reported phenomenon is that people will perform a quality assessment as almost a matter of routine, but that they won't actually use the quality assessment in their analysis and interpretation of results. So they're almost doing it as a tick box exercise. So here's an early report that showed that the quality assessment wasn't actually being used to interpret the results. So what this means for you practically is, in your write-up of your assignment, we will expect you to be able to clearly identify which are the better quality studies and those that are not, and to attach more certainty to the better quality studies than the poorer studies. So in terms of what we can do, we could present all the studies and then have a qualitative or narrative discussion of the risk of bias. The danger of that is that people are very influenced by exactly how we express this. We can restrict studies that have a low risk of bias, so that our results are based on the sounder studies, and we do what's called a sensitivity analysis, and we can actually do that for qualitative studies as well, to see the extent to which good quality studies and poor quality studies influence the overall results. Or we could graph the results according to risk of bias, so that we can actually see the relationship between the effect of the contributing studies and the risk of bias of the contributing studies, and so we're therefore able to make an interpretation of the likely risk of bias. And then finally, we could look at particular study features and analyze those in subgroups. So, for example, comparing studies that have adequate allocation concealment with those with inadequate allocation concealment, as expressed by the diamond.